Okay, so we've got the number of sides times the number of diagonals for each vertex. And I'm going to switch that. I know I said number of sides. I'd rather say number of vertices, right? Because that's kind of following the table better. So if we take how many vertices there are for each of our polygons, and if we do the number of vertices times how many diagonals from each vertice, and then divide that by 2, we should get the total diagonals. So your overall formula, I'm just going to scooch this down a little bit, is number of vertices, right? If it's an n-gon, it has n vertices and n sides, times number of vertices, and remember it was take away 3, and that's really coming from this part here. And then we divide by 2. That's number of vertices. Remember, this is number diagonals per vertice. And then that's 2 because we double counted them. Okay? So that's your general formula, and it's really, really similar to your handshake, except for number of people. You have, instead of n-1 handshakes, you have n-3. Remember, that's because you don't shake your own hand. I'm kind of looking at the pentagon here. You don't shake the hand of those next to, because that wouldn't be considered a diagonal. So that's why in this case it's -3 instead of -1. So let's just do some quick practice using our formula. What are the number of diagonals in a nonagon? And if we Google that, I'm going to just Google that on my phone. I'm going to be looking up the word nonagon. And a nonagon has 9 sides. So I'm going to make a little note here. Has 9 sides. So remember, n times n-3 divided by 2. Number of sides is n. Sides take away 3 divided by 2. That's going to be 54 cut into, which is 27. Okay, and then we want a dodecagon. And I'm just doing a quick Google search. And a dodecagon, if we Google it, has 12 sides. You would never be responsible to know these by heart or anything like that. I will always tell you how many sides if it's an unfamiliar word. I would only expect you to know like hexagon, octagon, that sort of thing. Okay, I'm plugging in the number of sides, which remember it's the same as the number of vertices, right? Number of sides is number of vertices. They're equivalent. Okay, if you plug that in, you should get 54 if you calculate that on your calculator. And then these last two are a little bit more interesting. They kind of ask you to go backwards. So if I say that you know it has 44 diagonals, right, that means n times n-3 over 2 has to equal 44. At this point, I say, okay, I have to backtrack and figure out what n is. So I do times 2. So I have n times n-3 equals 88. Now from here, if I distribute this, I have n squared minus 3n equals 88. If I subtract 88 on both sides, then I get n squared minus 3n minus 88 equals 0. And I have to factor this. I know it's an n and an n, just like it would be x and x, right? And then I need two numbers that multiply to be negative 88, but that add to be negative 3. So let's try some stuff on our calculator. On my calculator, I'm just going to do 88 divided by 4. So I'm just getting some factors of 88. So like 4 and 22. And those multiply to be 88, but they're too far apart to be equal to negative 3. So what if I do 88 divided by 8? 8 and 11 make 88, and those are 3 apart. If I want it to be a negative 3, I should make the 11 negative and the 8 positive. So it should be n minus 11 and n plus 8. Remember, you want what makes that 0. So a positive 11, n equals positive 11, and I did it again. N equals positive 11 and n equals negative 8. Negative doesn't make sense, so it was 11 sides. Last one is going to be the same setup. Okay, so we're going to have n minus 3 over 2 equals 1539. If I do 1539 times 2, we're going to have n times n minus 3 is equal to 3078, quite a large number. If I do the same steps and distribute and get everything on the same side, I'm going to have n squared minus 3n minus 3078 equals 0, just to save some time. So I need, similar to before, two things that multiply to be 3078 and that add to be a negative 3. So I'm going to just divide that by some numbers. Let's see. 3078 divided by 5. 3078 divided by 9. Right, I'm just kind of playing around with numbers. So I know that it has to be a pretty big number to have a difference of 3. So I'm going to play around with some numbers. And if I get to the point where I get restless, I might Google factor pairs of 3078. I'm going to play around for a minute, and then I might Google if I can't find something. So Miss Goldenberg gave up trying to guess it on her own because the numbers were too big. I did find that 54 times 57 works, and those are 3 apart. So I'm going to do minus 57 plus 54, which means n equals 57 or n equals negative 54, right? Because a negative 54 plus a positive would make that parentheses 0. So a negative amount of vertices or sides doesn't make sense. So your answer is 57. And as you've probably guessed, I have decided to have that be all of today's lesson. And the next lesson will be specifically looking at angles in a polygon. So today your big idea is how many diagonals are there in a polygon. So your big formula is the n times n minus 3 divided by 2 for a number of diagonals in an n-gon. Okay, so this is going to be kind of a day 2/3. We're going to spend a couple of days going over polygons. So tomorrow we will go over angles and different angle rules.